Today we will discuss about the three-dimensional heat transfer conduction equation in spherical coordinate system. Okay, we are going to derive this today. Okay, so to derive this we have to consider an spherical coordinate system, that the spherical coordinate system is the function of r and theta and phi. That what I am going to consider. Okay, I want to tell you this is a spherical coordinate system. Okay, that here it will be, I want to show you. Okay, this is the r and this is the phi and this will be the theta. Okay, it will be the theta, like this it will be there. Now I want to going to consider a element of this coordinate system, that here. Okay, draw carefully while drawing this sketch. It is difficult, somewhat difficult, but not much. Okay, follow what I do. Okay, this is the inner wall and parallel to that the another wall is there. Okay, so this is the two parallel walls. One is the near to the center, another one is the outer to the out of the center. Okay, this is the radius. Okay, that radius what I'm going to consider, and it will be the, for the element it will be the delta r. This will be the angle and it will be the r into delta theta. This is the vertical, and this is the r into delta theta. Now this distance will be the r into sine theta into delta phi will be the distance. Okay, this is the inner. Similarly, for the outer, r plus delta r into sine theta plus delta theta into delta pi will be the outer, this distance. Okay, for this one, r plus delta r into delta theta will be the this arc distance. Okay, be careful, and to visualize this is somewhat difficult, but you can do this one. Okay, now here, in order to derive this equation, we are going to consider three things. The first one is the heat flow. Okay, the first one is heat flow. How heat flow will be three directions. One is the r, theta and phi. The first one will be the in this, that is q r will be the heat input along with the radial distance, and q r plus delta r will be the heat output. Okay, this will be the radial direction. Next, tangential direction with respect to horizontal, it will be the q pi will be the input heat, and q pi plus delta pi. Okay, delta pi will be the output heat. Then radial distance, radial heat transfer with respect to vertical direction, it will be the q theta, and the output heat will be the q theta plus delta theta will be the output heat. Okay, qr, q theta, q pi will be the input heat, qr plus delta r, q theta plus delta theta, q pi plus delta pi will be the output heat. Now with respect to qr direction, this area will be considered as a a1. Okay, this area, that a1 is equals to r into delta theta into r into sine theta into delta pi. Next, for the radial vertical direction, this area we will going to consider. Okay, it will be the a2 area. A2 is equals to delta r into delta r into this is this distance and this distance, that will be the r into sine theta into delta pi. Next, a3 along with the pi direction, it will be this one, that is delta r into delta theta. These three area we are going to consider. Okay, this is the first thing. Next thing is the temperature. Okay, here temperature of the system is the function of coordinate system, that is spherical coordinate system r comma theta comma phi. The another one is, it is also function of time. Okay, it is used in steady flow. Okay, that is equals to 0. Okay, so these are we are going to consider. The third thing will be the assumptions. Okay, what we are going to assume while we deriving this equation. Okay, assumptions are, the first one is we are going to consider the material is the isotropic. Isotropic in the sense properties of the element is same at each and every element. Okay, that is isotropic. The next one is density. Okay, density of the element will be same. Okay, next the coefficient of heat. Okay, coefficient of heat, or what we call specific heat, that is C. Okay, this is the specific heat of the material is also the same at each and individual point of the body. Okay, this we are going to consider. Next, the third thing, the most important thing is energy balance equation. Here it will be energy balance equation. Okay, so it will tell us the fourth thing. The one is heat input plus heat generated, it is equals to heat output plus change in energy. This, combining all these four, it will give us heat energy balance equation. Okay, the three most important thing, one is the drawing the diagram and the heat flow and mentioning the area. The next one is the temperature functions and assumption and this energy balance equation. Okay, now we able to solve all the problems. Okay, the thing is heat input is, this is QR, Q theta, Q pi. Okay, I will write here QR plus Q theta plus Q pi plus heat generated will be G. It is equals to heat output. Heat output will be Q R plus delta R plus delta R plus Q theta plus delta theta plus Q pi plus delta pi plus change in heat energy, that is delta E by delta T. Okay, then I am going to shift these three into left side, that is, and take the minus common. Okay, Q R plus delta R minus Q R of plus Q R plus, theta plus delta theta minus Q theta plus Q pi plus delta pi minus Q pi of G. G is nothing but here heat into volume is equals to delta E is nothing but here it will be, I want to say, delta E is equals to energy at temperature T plus time T plus delta T minus energy at time T. The energy can be given by E is equals to M into C into T, where C is the specific heat, M is the mass, T is the temperature. Okay, with respect to all these, M is nothing but here, M is nothing but here, rho into V. Can I write here rho into V into C, temperature at T plus delta T minus temperature at T. Okay, this we have to consider. Then this whole equation is divided by V, so minus of Q R plus delta R minus Q R divided by V plus Q theta plus delta theta minus Q theta divided by V plus Q pi plus delta pi minus Q pi divided by V. Of V get cancelled, remaining will be Q. It is equals to rho, here volume get cancelled, the remaining will be rho into C into this will be delta T, what I left. So time temperature at time plus delta theta T plus delta T minus temperature at time T divided by TT. Okay, this we have to consider. Now we know that volume is nothing but we are considering the heat element, so we have to take the volume of that element. Okay, so here I am going to write here all the equation minus of Q R plus delta R minus Q R divided by volume is nothing but here volume is nothing but I want to dabba q pi divided by dabba pi plus here it will be q, it is equals to applying here also it will becomes the rho c dabba T divided by dabba T. Okay, temperature divided by time. Now as we have know that Q are nothing but from the Fourier law of heat conduction equation, that is it will says us minus Ka into Q is equals to minus Ka into dabba T by dabba X, where K is the thermal conductivity, A is the area, dabba T is nothing but change in temperature divided by length. Okay, similarly if we apply at each and every condition to the heat flow, QR is nothing but minus Ka A1 minus, that is QR is equals to minus k into a1 into dabba t by dabba distance will be delta r. It will be dabba r. Okay, then q theta will be minus k into a2 into dabba t by dabba. Distance will be here. How much it will be? This is the delta r. Next it will be traveling r into delta theta, r into delta theta. Q pi, it will be minus k into a 3 dabba t by r into sine theta into dabba pi. Okay, applying all this here, it will come them here. For the minus, it will each and every will get cancelled. Okay, the minus, and respective, if I keep this qr here, this area will get cancelled. Similarly, if I keep q theta here, this a2 and this a2 get cancelled. Okay, the remaining is r here. Okay, here also 1 by r square, like that. Similarly, okay, it will be k into this a1 get cancelled, dabba t by dabba r of dabba divided by dabba r. Okay, I will write this term as here k into dabba square t by dabba r square plus k into here the r into is there, it will becomes the 1 by r square. A2 get cancelled. The remaining is dabba square q theta divided by dabba theta square plus here r sin theta whole square 1 divided by r sin theta whole square. Here a3 get cancelled. Remaining is dabba square q pi divided by dabba pi whole square plus q is equals to rho c into, applying rho c into, it will be dabba t by dabba t. Okay, so this is the conduction equation. I'm sorry, it will be temperature, I think. Yes, it will be the temperature for dabba t by dabba t. Yes, it will be the temperature. Okay, so the remaining will be k into of dabba square by dabba square t by dabba r square plus 1 by r square into of dabba square t by dabba theta square plus 1 divided by r into sin theta whole square dabba square t by dabba pi whole square plus q is equals to rho c dabba t by dabba t. Okay, I will divide this term to whole here. It will becomes the by k and by k. So this k get cancelled. Remaining is dabba square t by dabba r square plus 1 by r square dabba square t by dabba theta whole square plus 1 divided by r into sin theta whole square dabba square t by dabba pi whole square plus q by k is equals to rho c by k dabba t by dabba t. For the steady, here I want to tell you each and every. Here T is the temperature, double partial differentiation of temperature with respect to R. Okay, here R is the radius. Okay, so temperature here theta is the radial distance. Okay, with respect to vertical direction, and here sin theta is the angle. R into sin theta becomes the, it will be the curve. Okay, here double partial differentiation of temperature with respect to pi. Pi is also the horizontal angle covered by the in spherical coordinate system. Q is nothing but the heat per meter cube, and K is the thermal conductivity of the material, is equals to rho is nothing but the density, and C is nothing but the specific heat divided by again thermal conductivity. Here partial differentiation of temperature with respect to time T. Now we are going to consider here, if the steady flow, then this term becomes 0. It will remain as dabba square t by dabba, it will becomes the is equal to 0. For the one dimension of spherical coordinate system, only this term will become, and this term and these three terms forms the one dimensional equation of in spherical coordinate system. For two dimension, these two term is there, and this term and this term. On combining it will form for 3-dimensional as it is the whole equation. Okay, this is about the 3-dimensional conduction equation of heat transfer in spherical coordinate system. Hope you have understand this equation. If you have any doubts, comment me below. I will try to explain again if you have any doubts. Okay, like this video and share and subscribe the channel. Okay, by the way, have a nice day.